So what does it take to stay competitive in aerospace manufacturing today? At Acutec Precision Aerospace, the answer is relentless improvement. Here in Meadville, Pennsylvania, we're stepping inside an employee-owned company that has been methodically built around continuous improvement and automation. Machines are arranged in lean cells, operators manage multiple systems, and custom software tracks performance in real time. When it comes to high-stakes aerospace components, Acutec shows what's possible when innovation meets discipline. Want to see what that transformation looks like in real time? Stick around and find out. Luke, we're here at Acutec. Tell us a little bit about what Acutec does, how you do it, and what sets you apart from other manufacturing facilities.
Yeah, Acutec is a primarily aerospace power generation company, and what sets us apart is our people, our technology, and our continuous improvement efforts through automation and additional digital technology that we employ here.
And as far as what we're about to see on this tour, this is one of how many plants that you have?
This is one of four, three of which are located in Pennsylvania, and the fourth is in St. Stephen, South Carolina.
And how many employees total?
We're right around 520 employees currently. So this next area that we're going to go into is going to be hot side engine components, 718 Inconel. One of the things that really sets us apart is that we're machining 718 Inconel 24/7 lights out. So if we look behind us here, we have a first operation in a horizontal. We have 5 pallets, an RPS system there. Now the part goes on a shunt fixture, and the fixture travels with the part through machining operations rather than loading that part at every operation over and over again. We'll see that downstream. After we're out of a horizontal, we go into a 10 pallet PH150 DMG Mori connected to a DMU50. And then from there, we're going into 2 DMG Mori lathes and then into a final 5-axis that also has a 10 pallet RPS on it as well. All of that, about 17 hours total machining time per part across all spindles. And we're able to, again, like I said, run lights out 24/7 on these.
So how many shifts do you run?
We run 2 shifts. We run a first shift and then we run a third shift. So the second shift, the gap is between first and third.
This episode of the Shop Tour series is sponsored by One Factory. Still dealing with spreadsheets, paper travelers, and quality systems that never make it to the shop floor? You're not alone. Many shops invest in software to deal with this, but if it's not being used at the machine, nothing changes. One Factory is a quality management system built for machine shops, with real-time inspection data at the point of manufacture, plus full traceability and audit-ready documentation. The QMS is designed to be up and running in weeks, not years, with an implementation process that's fast, easy, and doesn't require outside consultants. More than 550 manufacturers across 35 countries are already using One Factory, including those serving highly regulated industries such as aerospace, defense, and medical device manufacturing. Learn more by visiting onefactory.com.
Your dad started this shop, right? This
yeah,
company.
He was one of the founding investors, and he rallied a small core team and grew that from 1993 until 2013, from 17 people to 350 people.
Do you remember thinking, do you remember having an understanding of what your dad did?
Not really.
Not really, yeah.
No.
Yeah, I don't know.
I know he was stressed a lot.
He was stressed out a lot?
Yeah, yeah.
Yeah, this is impressive. I mean, just looking around, the guys at these stations are all pretty young.
Yeah. We have a younger workforce and generally a happier workforce as well. They like to come and they like to play with the technology. They like the access to the technology. You know, sometimes you work in a machine shop where you're hunting for an unused insert edge out of a Folgers can. That's not the case here. These guys have exactly what they need when they need it, and I think that makes their jobs a little more satisfying.
Yeah. There's a lot of thought that goes into this. This doesn't just happen by accident. We're just going to slap this here. There's a good area for the monitors.
Yep. Yeah, everything has a place, and there's a place for everything. You see we have the 5S benches, labeling. We have sister tooling at the bottom here that maybe not be used on this job, but maybe on the next one. And again, that's testament to the part family strategy. So this machine being a 9-axis Integrex can run anything, but we're saying we're going to put rod ends parts here. So all of his tooling is going to be built around cutting a rod end part instead of some of the other Integrex parts that we make that may be completely different and require different tooling.
I gave away 25% of the business, gave it away. Here's my thought. We had exiting, some of those original 17 people had retired. I didn't earn that, but they grew it. The people that were here before me, They earned that. I don't need any more equity in the company. So all of that original owner equity, I transferred over to the employees. And the idea there is, listen, we're at the bottom of what we're going to be. We had tremendous growth plans. 2019 was our record year. In fact, the first 3 months of 2020 were all record months for us. And then the bottom fell out. And so I said, all right, guys, we're going to build this back up, and you are going to benefit from the growth that you generate with this.
So we automate for a lot of different reasons. Sometimes it's capacity, sometimes capacity through throughput, and sometimes it's tasks that we don't want to waste our talented staff's time on, and sometimes it's ergonomics. So I don't have a capacity constraint for this part. I don't need this to run any more than I could have a human run it, but we have a 60-pound billet that a human that probably doesn't want to lift several times a day into the machine. So this automation effort was designed to kind of save an employee's back and to allow them to go do something else, matching their skill level. So we have a little jib crane that will connect to a magnet to be able to pick the part up and swing it in. It'll load on the racking tray. From the racking tray, that's as far as a human has to go with handling a part manually, although with a jib crane. And from there, the robot will load machine 1, flip the part in machine 1, load machine 2, and then stage the part finished on the pallet. Also, I don't want to mention that this was in partnership with the Ascend internship. Adam takes on automation interns very frequently throughout the summer. They work through like a capstone project every year they're here. This was one of those things this summer.
I've only seen 100 yards of the facility so far, but this is the kind of place that I would think if I was an intern, this would impress me as a modern factory, a modern machine shop, sorry. But when you think of our workforce issues, this seems like the kind of place that's going to get young people excited. First of all, when we walk in the building, you have a sign up front that says CNC Machinist.
Yes.
I imagine that's like a perennial sign. You just have it up all the time.
Absolutely, yeah.
But what I also noticed was that the shop floor staff is pretty young. Congrats on that. That's not easy. I guess, what is your philosophy on investing back into the company and staying on top of technology and using automation to allow your staff to do cool things and not get burned out?
It's fun to let people explore, right? So and get creative, and you have to balance that out with a return on that investment. But if you give people enough freedom to try things, and hey, if that doesn't work, all right, try the next thing. What did we learn? When we have a scrap part, I always say, okay, we just invested $600 in learning something. What did we learn from that $600 investment?
Jump over. I want to see a one factory and like what the machinist interface with. We can get that at a different work center.
You guys use one factory?
Yeah, we do use one factory.
I love one factory.
We'll hit that up when we get down here. We'll go through how the machinist interfaces with one factory.
Can I ask, just real quick before we get too far, the way that you have this facility laid out, I just noticed a lot of inspection equipment right in the middle of the shop floor.
Yeah, that's a great observation.
So talk about the reason for that.
Yep, so we have our in-process inspectors that live where the products are being developed, and they have their cycle count frequencies that they're hitting in real time, so that way when these parts get to final inspection, it's a visual and out the door. They're fully inspected in real time as they run. The machinist is recording in one factory. The inspectors are simultaneously recording in that same one factory routine as they're able to work in that same routine in different locations. So the in-process inspectors are going to be responsible for maybe molded features, checking some radiuses and things like that. They're going to be running CMM samples, and all that's designed to keep the machinist at the machine, running and checking with the hard gauging that they've been issued.
Yeah, and all of that data and information is automatically uploaded into one factory like that, right?
It is, from both the Krista Apex CMMs and the Mitsui MyStar CMMs automatically upload into one factory.
That's awesome.
Yeah.
When I first started learning about One Factory, I met the CEO and founder of the company, and he, I just thought it was kind of an auto ballooning platform, but it's so much more than that.
It really is, yeah. So kind of our workflow, once it goes through the planning team, the drawings get automatically bubbled, they get loaded. We create an inspection plan based on risk assessment for each feature. We have gauges loaded, so it comes to the floor with frequencies, with the gauge selections, everything that the machinist needs to complete the inspection of their parts.
That's great.
So we can see on one factory, we get the statistical process control to see where we're actually running on that feature. We have control limits set, and then One Factory is also capable of handling the sampling frequency, which is indicated to the machinist on the left by the white and blue boxes, so they know what they're responsible for recording at what frequency of part number.
Wow. Yeah, One Factory has really evolved. So when I did a feature on them right when they started, I have not seen any of these capabilities back then.
What's nice about One Factory is we do kind of have like a good, we have a good relationship with One Factory and design influence on if we need something to do it a little different, their software developers can adapt to that. So we've gone through some continuous improvement iterations with them as well. So I don't doubt that it would look different than if you hadn't seen it maybe a year ago.
I am fascinated by, I guess, continually improving. And the lean manufacturing piece of that, again, it's the combination of data and people and tangible results. I love seeing. Like that's the thing that's so great about manufacturing that I think genuinely society craves, because so much of our time is spent online in a digital world, to see tangible results. And especially at smaller organizations where you can make a change and then see the result of that within, a couple days, a couple hours, that is cool.
So this is a unique cell here that came, remember we talked a little bit about capacity and throughput and solving problems for the customer, and also problems for the machinist. This involves all of those, as the product that's being developed here, customer demand went from about 90 a week to 120. In order to hit 90 a week, the machinists were working like 50 hours, 55 hours in some cases to make, coming in on a Saturday, trying to hit those numbers to satisfy the customer. So what we did was we created what's a collaborative where a human and a robot work together. So the human can run the lathes, which can overproduce about 2 to 1. The mill is the tall bar, so we automated the mill, obviously. But this will run after he goes home and before the night shift comes in, and after night shift goes home, and on the weekends it just keeps running. Now we can hit about 130 parts a week, and they can work 40 to 45 hours to be able to manage that.
Wow, that's fantastic.
Yeah. So you can see we have a vertical and a horizontal holding configuration. There's two different pallet types. So 2 different operations that are running simultaneously. So we use DMU's probing software, which is Siemens based, really powerful software, where this pin is about 60 thousandths difference in height from that pin. Wow. So it comes in and so it's not just identifying, it's saying, okay, if it's this tall, run that program. If it's that tall, run that program. So there's some logic built into it.
Wow, that's
yeah.
amazing.
Yeah, so that's, Adam's team in production, we work together, we say, right from the very beginning, before we even build something, what could go wrong, okay? What do we anticipate going wrong? We've had failures of imagination in the past, and we learn from those. So every time we do a new automation effort, we have more and more what we call poke-yoke mistake proofing happening.
When you're really deep in the supply chain in a machine shop, oftentimes you disconnect from, here's a widget, here's the print, here's the GD&T. What is its actual function and where is it in the world? We make a guidebook of here are the parts that we make for these platforms. And then when you go to the Blackhawk and the crew chief there, or the maintenance tech who's there, and they're excited to see the people that make this, and they're like, oh, you make the stuff that if that's bad, I have a bad day. Like, yeah, well, we're making sure that you have a good day.
So these machines by nature are automated. So these are gantry loaded NZX machines from DMG Mooring. So then to add on top of that, Adam's team has then taken automation and merged it with DMG's automation.
This linear track, or this 7th axis, is the largest they've ever built. And actually we've considered adding another 12 to 14 feet on it to be able to accommodate unloading this 4th machine. And that's kind of in the works. If that capacity becomes a problem, that we'll extend this down. It basically lets it know by a switch, hey, this part just came out. It knows what part it's grabbing out, and it's going to go through that same series of processes no matter what the part. It's going to go through a couple dip tanks, it's going to go through a blow off, and then either, depending on its register right now, it's going to go to the CMM, or it's going to go place it in one of its finish stations.
This is a brilliant setup. Is part of your job looking for other opportunities throughout the plant to systematize automation like that?
Absolutely, especially the 7th axis. Once we got our feet wet and our wheels going with the 7th axis, we see a lot of opportunities, but everything comes at a price. So it's finding the right opportunities. So we rely on new work coming in to help fund new projects, and a sales strategy is starting to look at different jobs that are well suited that we could dedicate for.
Sounds fun.
Really? We play with robots all day.
To folks who might not have an understanding of what happens in machine shops, and not just machine shops, but really highly automated facilities like this, why should they care that not only that manufacturing exists here, but that we have incredible capabilities at places like Acutec that are doing amazing things with extremely highly technical equipment? Why does that matter? Why should anyone care?
We have a machinist who makes chainmail, like, for fun. You know, guys who are making knives and forging with home forge. So the accessibility of some of that equipment for hobbies, there's a lot of that. And the craftsmanship, if you can connect people in that way to, okay, well, now we just scale it, or we do it with even, you know, $1 million computers. Like, I tell kids, like, these are $1 million computers that cut metal. It makes it a lot more accessible and fascinating and interesting. If we approach it less from a victim mentality and more from a opportunity, like, here's the opportunity and here's the unleashing of American creativity and resourcefulness, I think the better off we'll be.
This episode of the Shop Tour series is brought to you by Manufacturing Connected. Manufacturing Connected is a digital platform from Modern Machine Shop's publisher, Gardner Business Media, focused on the issues shaping manufacturing, regardless of the processes you use or the markets that you serve. That includes everything from automation and additive manufacturing to capital investment and hiring. Go to mfgconnected.com to sign up for our weekly newsletter. In each issue, you'll get quick reads, access to in-depth interviews, and useful links about the issues that matter to your business. Get connected at mfgconnected.com.